Hello students. Today we would like to discuss about nitrogen fixation, how the nitrogen is fixed. So far we had read about different roles of nitrogen in plants. The major substance in plants next to water was building blocks and constituent elements like chlorophyll, cytochromes, alkaloids, and many vitamins. These play a very important role in metabolism, growth, reproduction, and heredity. So, students, I introduce myself that I am Dr. Preeti Mathur, Associate Professor, Department of Zoology, SPC, Government College, Ajmer. So, students, so far we read about the role of nitrogen in plants, then also about the sources of nitrogen and how the nitrogen is fixed and the various types of nitrogen fixation, non biological and biological. In biological, we studied about non symbiotic and symbiotic. So, the nitrogen fixation is a very important part where if we study about the basic structure of the nodules and the formation of root nodules in leguminous plants. Root nodules are very important, and when we study these we come to know about how the nitrogen is being fixed in the leguminous plants in the root nodules. So students, we would like to study about the biochemistry of nitrogen fixation. Basic requirements for nitrogen fixation are the nitrogenase and hydrogenase enzyme. Then the protective mechanism against oxygen, ferredoxin, hydrogen releasing system or electron donor, that is pyruvic acid or glucose or sucrose. Constant supply of ATP. What is ATP, students? It is adenosine triphosphate. Then the coenzymes and cofactors, that is TPP and coenzyme A. Inorganic phosphate and magnesium ions. Cobalt and molybdenum and a carbon compound. In the nitrogen fixation, nitrogenase enzyme plays key role. Active in anaerobic condition. It is active in anaerobic condition also, and it is made up of two protein subunits. Non-heme-iron protein, that is Fe protein or dinitrogen reductase. Secondly, iron molybdenum protein, MOFE protein or dinitrogenase. Then comes the iron protein, which reacts with ATP and reduces second subunit, which ultimately reduces nitrogen into ammonia. So here the formula you can see clearly: nitrogen, 2 atoms of nitrogen plus 6 atoms of hydrogen plus 6 electrons give 2 ammonia molecules. Now in this slide you can see that the reduction of nitrogen into ammonia requires 6 protons and 6 electrons. 12 molecules of ATP required. These are required, and one pair of electron requires 4 ATP. The modified equation is now 2 atoms of nitrogen plus 8 atoms of hydrogen ions plus 8 electrons gives 2 molecules of ammonia plus 2 hydrogen, 2 free hydrogen, 2 molecules. So the hydrogen produced is catalyzed into protons and electrons by hydrogenase. So hydrogen, in presence of hydrogenase enzyme, it gives two hydrogen ion and two electrons. So after studying about the various equations and processes and also learning about the different types of enzymes in the presence of which the reaction it occurs. Now, the pathway of nitrogen fixation in root nodules. Here, glucose 6 phosphate acts as an electron donor. It acts as an electron donor. First of all, sucrose synthesized in leaves. This sucrose is synthesized in the leaves. This sucrose is also present in fruits, and then the glucose and fructose are also found, and then glucose 6 phosphate is then formed finally. Now glucose 6 phosphate is converted to phosphogluconic acid. Phosphogluconic acid. Glucose 6 phosphate plus NADP plus 1 molecule of water, it gives 6 phosphogluconic acid plus NADPH and 1 molecule of hydrogen, that is hydrogen ion. Now NADPH donates electrons to ferredoxin, protons released and ferredoxin is reduced. This reduced ferredoxin acts as electron carrier, donate electron to iron protein to reduce it. Electrons released from ferredoxin thus oxidized. This reduced iron protein combines with ATP molecule in the presence of magnesium ions. Magnesium ions. Second subunit is activated and reduced. Thirdly, it donates electrons to nitrogen, from nitrogen to ammonia. Enzymes set free after complete reduction of nitrogen to ammonia. Now here you can see the table clearly, and then you will come to know and you will understand it more nicely. I end my lecture over here, and I think you have very well understood about the fixation of nitrogen in the nitrogenous plants and in the soils, and then you read about various processes and equations and the various enzymes which take place in nitrogen fixation. I stop here. I really thank you for patiently hearing me. I repeat my name. My name is Dr. Preeti Mathur, Associate Professor, Department of Zoology, SPC, Government College, Ajmer. My email address is given. If you have any query, you can phone me or talk to me on my mail. Thank you.